Right, the topic is based on differentiation. That's C3, Core Mathematics 3, please. There are three types of differentiations one needs to know in this chapter. That's called chain rule, product rule, and quotient rule. We do the rest of the two, but let's start with the chain rule. There is a small question here which says y equals to 2x plus 1 whole square. Our aim is to differentiate this with respect to x. So before applying the chain rule, let's do this using the C2 style that we know, right? So we say y is equals to, we expand the bracket first, which is 4x square, and then plus 4x plus 1 after you expand the bracket. Once we expand the bracket, we say now we are ready to differentiate. So it should be dy over dx is equals to 2 times 4, 8x and plus 4. That's what you get. So that's the answer using the normal method. Now let's solve this using the chain rule and try and understand the meaning of chain rule. So I'm taking the same question. I'm supposed to get the same answer. The question is y equals to 2x plus 1 whole square. The first few sums I will do slowly. We use a method called substitution. We consider the bracket, that 2x plus 1, to be another letter, a u or p or q. So let's start and say let u equals to 2x plus 1, just the bracket only. That implies, now once you say that is u, the question changes now as y equals to u square. That's what you get. So there are two equations we do have. The first one is u equals to 2x plus 1. We differentiate u with respect to x. It's like, if you watch the screen please, this is the x-axis and that's the u-axis for you. So we can differentiate u with respect to x. And that comes down to be du over dx is equals to just a 2. Okay, that's done. Now let's differentiate y equals to u square. Now this is exactly same as, there's an axis here, that's the y-axis and that's the u-axis like. So we can in fact differentiate y with respect to u. So we have dy over du is equals to u square is 2u, right? Because x square is 2x. So we have two types. Our aim is to find dy over dx. That's what we actually need, right? So I have a du over dx, dy over du. If I multiply those two, do you agree? The du and du cancels out, we get dy over dx. So that's the plan. So now I can say du over dx, take this one, multiply by dy over du, I get dy over dx, right? Because those two can cancel out. But I know that du over dx is a 2 and dy over du is 2u, right? So 2 times a 2u will give me 4u, and the left hand side, those two cancel out. I have dy over dx, right? That's what I got. Then we simply substitute the u back into the question. U was 2x plus 1. So we can write 4 bracket 2x plus 1, which comes down to 8x plus 4, which is exactly same as the one that we got by using the normal method. Now this method looks pretty simple, easy. This looks very, very big. But as you go on solving the questions, you will notice that this is much easier, because what happens if this question is not just a square, it is 2x plus 1 to the power 12. You cannot open the bracket 12 times, you see. That's when this chain rule is pretty handy to solve these sums. So that's the meaning of chain rule. We assume the bracket to be a letter and we differentiate this, we differentiate that, multiply those two down. we go for one more example. Well, there are some shortcuts. I will come back to that later. Let's do one more question here. 3x plus 2 whole square. We need to differentiate. This is y equals to. So what we do first, we say let u equals to 3x plus 2. That's what we write. Then what happens once you do that? The question now changes. Watch. Implies this is y, right? So we say y equals to, that's a u, so your question now becomes a u square. Watch. We differentiate this with respect to x, so we have du over dx is equals to just a 3, and then we differentiate that with respect to y. Okay, dy over du is u squares differentiation is 2u, right? If it's a p square, that will be a 2p. Okay, we got those two. Now we simply multiply these two to get dy over dx. So let's write the steps first for few sums. Du over dx multiplied by dy over du is equals to. So we substitute du over dx value, which is 3, and multiply by dy over du, which is a 2u, right? So finally we have a 6u, right? The left hand side du's cancel out. We achieved our aim because we wanted dy over dx. Then we mustn't stop the sum here. We have to substitute that u back into the final answer. So we have 6 bracket, that's a 3x plus 2, right? 3x plus 2. Then we simply open this bracket to get the answer. 6 times 3, 18, x there, plus 6 times 2, 12, or maybe you can leave it like that also, nothing wrong. Right, so that's the chain rule, very important concept, right? So let's try one more question, right, before I go for the shortcut. Chain rule, please. Question 2. Now I have question 3 on the board. On the screen here, that's y equals to, please, and we call the bracket to be u. So let u equals to 2x square plus 3 bracket close to the minus 2. What happens once I say that? I get the question now changes to y equals to, that's u to the power minus 2. That's what happens. Then we differentiate this, we differentiate that. See how we get on. This is du. Oh, sorry, there's no minus 2, please, right? So du over d, just the bracket only is u, please. Sorry, there's no minus 2. Du over dx is equals to 2 times 2, 4x, plus that's 0. So we stop there, and here dy over, this is du over dx. dy over du is equals to minus 2 u to the power minus 2 minus 1, which is minus 3. That's what we get. Right? So now we multiply these two to get dy over dx. Right? So let's write the steps, please. That's du over dx multiplied by dy over du is equals to, this one is a 4x multiplied by, that's a minus 2u to the minus 3. So we simplify this a little bit. Minus 2 times 4x minus 8x, and then I have times u to the power minus 3. As we said, we substitute the u back into the final answer there. So we have minus 8x stays there, and inside the bracket we called u equals to 2x squared plus 3 only, right? So it's 2x squared plus 3 to the power minus 3. So we can leave the answer like that, nothing wrong. But if you want to remove the minus and bring this to the denominator, that's still okay. So those are the three examples that we have done based on chain rule. Du over dx, and then we have dy over du. Then we multiply those two to get dy over dx, which is the gradient of the given function. Okay, now I will teach you a shortcut based on the same chain rule. Let's see what happens. I'm going to the same question, the first one that we have done, and do that by shortcut, right? The first question was y equals to 2x plus 1 whole square, right? What we do, we consider that as a box. Say y equals to a box square. If you want to find dy over dx, all that you do, box square is 2 times the box. That's the differentiation of a box square. If something's cube is 3 times the same thing square, all right? So we write that 2x plus 1. Then we multiply by the differentiation of that, which is a 2. So we get 2 times the 2, 4, bracket 2x plus 1, and then it's going to be 8x plus 4. So that's the shortcut instead of calling it u, right? But that method is very important in solving few questions in C4. That's the shortcut. So let's do one question with a shortcut. Question, say, my own sum, for example. Y equals to 5x cubed plus 8 to the power 10, right? Then we say something to the power 10, right, is 10 times the same thing to the power 9, which is a 5x cubed and plus 8. Then we multiply by differentiation of the bracket, which is 15x squared, right, and that is 0. So finally we simplify those two terms, 15 times 10, 150x squared, and bracket to the power 9. That's how it works. Okay, so that's the shortcut for the chain rule. Even this question also, it looks very big, but this can be solved using the shortcut. I will explain here itself. Can you please watch this screen? Something to the minus 2, if you differentiate, you're supposed to get minus 2, watch there, minus 2, the same thing to the minus 3. So this is actually that. And then you differentiate the bracket, you should get a 4x. So I will do the remaining 2 questions that I have by means of the shortcut, please, right? So there you go. That's the question, 1 over 4x plus 1 to the power 2 there. Let's write it as 1 is 1. So it's a 4x plus 1 to the power minus 2, right? See how we do this in shortcut, not the use story, right? Let's call that as a box or something to the power minus 2. This is y please. So dy over dx is equals to, watch very carefully, something to the minus 2 is, the power comes to the front, you all know, to the power minus 2 minus 1, which is minus 3. So that's 4x plus 1 comes back, times, differentiate the bracket, which is a 4. So comes down to minus 2 times 4, minus 8, bracket to the power minus 3. That's a 4x plus 1, please. You can leave the answer like that. Okay, pretty easy, right? If you didn't understand that, let's try one more question there, the own sum, right? We have y is equals to x cubed plus 3x squared plus 5x minus 1 to the power, say, 100, right? You cannot open this bracket by itself and say multiply 100 times, right? So the chain rule is very, very nice. Let's do the shortcut. Dy over dx is equals to something to the power 100 is 100 times the same thing to the power 99. That you know, right? So it's a x cubed plus 3x squared plus 5x and minus 1. Then you differentiate the bracket and multiply. So that's going to be a 3x squared plus that's a 6x and plus 5. So you are allowed to leave the answer like this. Nobody expects you to open that bracket with the power 99. Okay, so shortcuts, very, very nice to solve these sums using the chain rule. Question number 5, right? I'm going for the shortcut only, please. So this is y is equals to. So dy over dx is equals to something to the power 5. Differentiation is 5 times the same thing to the power 4. the power comes down by 1. You know that, right? 4x cubed plus x. Then we are supposed to multiply by the differentiation of the bracket, which is 3 times of 4, 12x squared, and then plus differentiation of x is 1. That's it. You can leave it like this unless there is a common factor, but this is fine. So that's the shortcut. If you want to do the long one, you still can do by calling this as u. So watch there. If you do u is equals to 4x cubed and plus x. That's all. Just call that bracket as u. So the question now becomes y is equals to u to the power 5. Watch. And that is du over dx is equals to 3 fourths 12 and x squared plus 1. So that's what we do have here. And this one, if you differentiate with respect to u, we have 5u to the power 4, because that's u to the 5. Then we multiply those two, right? Remember, we times those two so that the du's cancel out. Means we simply times those two. That's what it means. So we have 12x squared plus 1 in a bracket times 5 u to the 4, right? U was that 4x cubed plus x. So we say 4x cubed plus x to the power 4. That's what we will write. And see whether we got the same answer there. The 5 was in the front. This is here. And the 12x squared plus 1 is in the end. So this, it does work, right? So the shortcut is very important. It's the last question I want you to try. Question number 6. By shortcut and the long method both, please, right? So I am taking one, this sum using the shortcut only. Let's just solve that. So dy over dx is equals to something to the power 4 is 4 times the same thing to the power 3, which is x squared minus 5x and plus 6. Then times by the differentiation of the bracket. Don't forget that, please. So which is actually 2x minus 5, and you leave the answer like that. Mind you, this is the gradient of that curve. If they ask you to find the equation of the tangent or normal, they will give you a point, and you know how to do that. So I'm just concentrating on the chain rule, product rule, and quotient rule for the time being. Later on, we will do the equations of normals and tangents. So we finished the chain rule. We did 6 sums, right? Now let's understand the meaning of product rule. Product rule, product says multiply, right? The question looks like y equals to function x multiplied by gx. So there are two functions with a multiplication sign between them. That's when you say, okay, this is one function, that's one, I can use product rule. The formula is this. The textbooks say dy over dx is equals to differentiate the first one, multiply by the second. This you don't have to prove. If you know how to use it, that's enough. Plus, always plus, copy the first one the same and multiply by the differentiation of the second one. So what's that? F dash x times gx plus g dash x times fx. Differentiate the first one, multiply by the second. Differentiate the second one, multiply by the first, and then add them. So because it looks very long, what I do, I call them as a u and v, right? Let's call it uv. So the formula now changes to u dash v, right? U dash v, dash means that's du over dx, right? Plus uv dash. That's all. So remember that. If you cannot remember, the shortcut is this. uv whole dash means that's the dy over dx. Just write uv plus uv, right? Dash comes to the first one and there for the second one. That's all. That's about the product rule, and question must look like that. So I want to solve one question again using the C2 style, and then we will do the long way. Okay. So I'm taking one problem here. The question is this. Suppose we have y equals to 2x plus 1 multiplied by 3x minus 2. Using C1, C2 style, if you need to differentiate this, what will you do? We first open the bracket. So 2 times 3, 6x square minus 4 plus 3, which is a minus x and minus 2. That's what I get after the expansion. Then we do dy over dx because it's ready to be differentiated. 2 times a 6, 12x minus differentiation of x is 1, that's 0. So that's the answer. That's normal style to do. So let's call this as function x or a u, that as v. So the question looks like u times v, all right. So I'm going to do the same sum here. U is this and v is that. Okay, so watch there. U equals to 2x plus 1. And then I will write here v equals to 3x minus 2. Guys, watch, it's the same sum, right? Now, let's find the differentiation here itself, right? U dash means du over dx, which is a 2. And v dash is a 3. That's all. Once you write those 4, you're ready to write the final answer. The rule is u dash v plus uv dash. Remember that, right? Don't forget. U dash is a 2. So let's write a 2. Multiplied by v is 3x minus 2. So that's inside the bracket, 3x minus 2. Plus u is 2x plus 1. So that's inside the bracket, 2x plus 1. Multiplied by v dash, which is a 3. So that's all it is. Let's open the brackets and collect the like terms. We are supposed to get that. So 2 3s are 6x minus 2 times 2, 4 plus 3 times 2, 6x plus 3. So 6 is a 12x and minus 1. We still get the same answer. These two answers will be same. Once again, this method might seem to be very simple to solve the sum instead of using the product rule. But as the question becomes bigger, say it's 2x plus 1 to the power 5, 3x minus 2 to the power 3, then the problem starts. Okay, so we understood the meaning of the product rule. Just remember that u dash v plus uv dash. I have a question here. Let's try example 1. Do we have two functions? That's a times sign between them. So that's the function x, that's gx like. So let u equals to x squared. And then say v equals to the second bracket, which is 2x plus 1. Now simply go and find what's u dash. Is a 2x. And v dash will be a 2. Listen, you can simply open the bracket with x squared and then solve. Nothing wrong. But I'm trying to explain how this product rule is used, okay? The formula is u dash v plus uv dash. That's what we have. So now u dash is at 2x. So it's a simple substitution now. 2x, v is inside the bracket there, which is 2x plus 1 there, right? And plus u, which is x squared, watch. And v dash is a